Okay, we're going to jump right into the panel discussion. Do you guys have a mic that you can kind of hand back and forth? So I'll kind of seed with questions, and you guys can discuss amongst yourselves, so don't feel like you're answering to me. Like, have a conversation here. So Ty, we haven't met. I'm Eric. So I'm going to pick on you first. Perfect, go for it. One of your slides said something about testing, proving the correctness of code.
Yeah.
So what do you guys think about that?
So first, to avoid nitpicking in the room, I heard feedback that proving correctness from a functional programmer or mathematical perspective is probably a bad word to choose. I chose it anyway because using a statement like validates correctness or something else that like implies that you're seeking correctness in your test case just didn't really get the point across that I was trying to make. Without having tests, how do you know that in certain situations that code actually works? You can only manually test so much of it. And when you start pushing that out to get data from your customers, they're going to experience many of these unknown scenarios. So having testing gives you a fundamental foundation for this level of confidence that you can move forward with, knowing that your code base is more hardened than it would be with unknown data. Right?
I like tests too.
Android is an untestable mess, and if you're writing tests, you'll soon delete them because you'll find that you're spending so much time maintaining the test infrastructure, setting up the emulators, waiting for everything to work. You're better off just writing it correctly the first time.
So I approach this by not writing any bugs. I don't know about you guys. No, we actually have two ways we approach testing. We have internal components that are, things like our message formatter or things that are very tricky, and it's important to not mess them up when we go back and add a new component. But then we also have a QA engineer who does things that are more like, what's the word I'm looking for? Like, not manual, but from the audience.
Automated. Words. Things. Scenario-based testing. Lies.
This is fun. No, more just like full regression tests and things like that through the app. And I think I liked your point about focusing on the most important things to test and not, because if you're looking for 100% test coverage, like it's not going to happen. Like it's not. So focusing on the things that it's a really big problem if you break it down the road and you might not notice. Like I think that's a good kind of trade-off.
I actually want to ask you guys what fraction of your tests are of each style. Like what fraction are plain pure Java unit tests? What fraction are run on an emulator tests? Like what's the mix?
I don't know, but I'm going to guess. It's only in the last year or two that we finally tamed Espresso, learned how to use it effectively. And as that has happened, and as we've finally gotten good at spinning up VMs on demand and that kind of a thing, I think the ratio of Espresso to unit tests has really started climbing high in the Espresso direction, because once it's working, it's frankly easier to write. I'll spend a lot less time thinking about, well, is this in the view? Is this in the presenter? Do I like presenters this week anyway? And I can spend more time in, when I hit this button, I want to go to this screen, and if I don't, something bad happened. And I think the main lesson we learned to make our Espresso tests not flaky and more reliable is to do waiting all of the time. You never want to assert this button is showing. You always want to say, wait until this button is showing and then give up after a few seconds, because that'll settle down. And if everything is expressed in that way, a lot of stuff just kind of accidentally keeps working.
So working at Twitter on the SDK side of things, we have a little bit of a different perspective than I think a lot of common app developers do, because when we write libraries and SDKs and ship those out, we don't have the same sort of update cycle that a normal app developer has. So if you roll out a bug to your consumers, you may see that like spike up in Crashlytics or Bugsnag or Acro or whatever you're using, and hotfix it and roll that out to your customers pretty quick. Everybody that has auto update on will get that fixed. But when an SDK rolls out a bug, it often takes much longer to notice that there's an issue. And once that issue is noticed and fixed by the SDK provider, then it takes much longer for the consumer of those SDKs to get that implemented into their code base, test it with their scenarios, and then push that out to their customers as well. I mean, oftentimes many months are taken between these updates getting pushed out. So we take the approach that we have to have a very rigorous testing process. Most of these are through unit tests. Integration tests on our SDKs are extremely valuable when it comes to some of the more UI-related things like Digits. It's our SMS sign-on SDK. It uses Espresso, and it has a lot of integration tests as well. But for things like Crashlytics, most of the tests are unit tests. Probably 90+% are unit tests, with some integration tests hitting servers and making sure that the appropriate things are pushed up there. But the majority of it is completely unit test, and anything that we're running on a regular basis from the development machine is entirely unit testing from that perspective.
All right, so everybody loves tests. It's all happy. So obviously, with a talk like nobody got time to write tests, your implication there is that actually writing tests helps with productivity in the long haul. So you're taking like a big picture view. I'm wondering if anybody in the panel actually has a deliberate way to measure engineering productivity. Like, can you quantify that? Like, how much productivity are you losing to things like broken builds and broken tests? And is there a way to measure that stuff?
We do something really, really good for this, which is that we've got 3 people who work on the iOS app and 3 people who work on the Android app, and we race them. So if the Android app is done on the 28th and the iOS app is done on the 31st, then there are no productivity problems. And the iOS team then has productivity problems. So it's an unfair comparison.
Which team is faster?
So 1/3 of our Android engineers are named Jake Wharton.
All right, so you got separate iOS, Android engineers. I'll just throw this out there. Code sharing across iOS and Android is highly overrated. Discuss.
I have opinions about this. My very first mobile engineering job was at a place that used Xamarin and Mono to do code sharing. It does sound great, doesn't it? It sounds great, and it's nice to be able to tell people that you can have feature parity right away, and it mostly works, but when it doesn't, it really doesn't. I found the amount of time you waste trying to track down bugs that end up being because there's 2 garbage collectors that don't know about each other, or because iOS and Android have a different number of processes. Or maybe you want to use the latest support library, but that's not released for your framework yet. So either you wait or you write your own JNI bindings. It winds up not being worth it. I don't know if y'all have opinions about this, but
I know what I want to believe, and then I know what I live. So we have some amount of shared C code, and that gets written and maintained by the guys who want to deal with the C code, who tend to be embedded software engineers. And then there's a couple of victims on either platform who kind of create the bindings between those, and the rest of us just pray to God that we don't have to debug into that stuff. Meanwhile, we have a number of friends at Google who have been evangelizing GWT and J2OBC as code transliteration ways to get a lot of sharing. They claim up to 70% of non-UI code, on top of which you write normal native UI code. And we keep being this close to actually putting that to the test on a particular library that we are sharing with Java Server and JavaScript clients and Android. But it's always a kind of another few weeks away. So ask again in a few months. Maybe we'll have a better answer.
Jesse, do you want to go first?
Sure. I'll go third. On Friday, we shipped an update to our app, Square Cache, and we shipped a shared library so we can end up sharing really like sort of mechanical business logic code between iOS, Android, our web app, our server, And one thing that this amazing library we found also allows us to do is to do hot updates to the iOS and Android apps. So we can have the Android app and the iOS app out in the wild, and we can say, you know what, I want to change the way that this particular screen, that the messaging on it. And it sounded a little bit too good to be true, but the shared programming language we're using is JavaScript, and we shipped JavaScript in Square Cache on Friday, and so far it's working really, really well. And we're just doing it for like really simple things like, suppose you're looking at a payment, and the payment completed on October 31st. Well, on October 31st, you'd say, your payment completed today, and the next day you say, payment completed yesterday, and then the next day you say, your payment completed 2 days ago. And what we were thinking is, like, how do we get these like very sort of like nice, friendly human strings so that we get them exactly right on each platform, and so that we can have like really, really nice copy, because it can say something like, your donation to such and such was complete this afternoon, and we want to have like really, really rich behavior, but we also want to not implement it 4 times. And so JavaScript is working really well thus far. It's very early days for it, but look forward to a post on the corner where we're going to sort of explain what we did, how we're not using web views, but we are using JavaScript.
I think that there's quite a few different levels of shared code that we should be talking about. There's things like Xamarin and Mono, which tries to replace the entire Android stack. It says, there's a platform built by Google or by Apple, and we're going to assume that at some level, like, all of the things under the hood are the same, and we want to provide a big abstraction on top of that. And as they put out new features and new APIs and changes, we'll try to be as quick as possible to update those. We'll always be lagging behind. That introduces a lot of problems to the developer, a lot of pain points. You don't get to take advantage of the native tool chains of the platforms, which are always going to be generally going to be more mature, moving faster. And when you want to learn and have other people hop into the code base, you have a little more variety with that. But then you can kind of move down into some like less overarching concepts. Something like shared code for the payment processor in Square is probably a great example, where you're not doing the entire app in that. You have a specific thing that has a need for it to run in that level. Now, you might still have pain for you're not getting to use the full developer tools. Maybe they were writing that C and not in Android Studio. They're needing to test that on iOS and Android. So testing that is probably more challenging. But that's probably a much better use case for shared code than the entire full platform. And then kind of third, you have it's an app replacement, but it's also not doing it to native code. It's the things like PhoneGap and Cordova. That kind of try to take JavaScript and then abstract away many of the complexities of app development, not just the APIs into your language. With Mono or with Xamarin, it says, well, it pretty much looks like the Android APIs you're hitting, but you're using C# instead of Java. But with something like PhoneGap, it says, like, you maybe don't really need to understand multi-threading very much because it's JavaScript. And it tries to remove some of these abstractions and make it a little more friendly to web developers. And I feel like that's inherently flawed and produces much poorer user experiences than either of the other two, even with kind of my negative opinion on Xamarin and Mono as well.
Yeah, it seems to me like the technical decision also influences the teamwork. And like what Ray, you were hinting at is when you do a C library, it ends up being owned by a separate team that understands the language. Mm-hmm. And it seems like another common theme here is that you don't typically share UI stuff. It's a layer below that's agnostic. Because one thing that strikes me, maybe I'm getting too much into the panel, but I can't resist. It seems like if you get into UI stuff, then the org of your team, like you'll tend to see maybe a preference towards iOS and a neglect for the Android side. It's almost inevitable that you won't see a fair treatment across those platforms. So that's my 2 cents, bad moderator. Sometimes we use the word Android engineer. I'm going to propose there's no such thing as an Android engineer. We're just engineers. And I think that's even more true today than it was 3-4 years ago. I find that we just interview for generalist engineers and hire them, and they can learn the platform. What do you guys think about that? Is there a need for specialist engineers these days? And is it different than it was a few years ago?
We've definitely been interviewing specifically for Android specialists because we're still very early on in our app's life cycle. And I think, at other jobs, there have been training programs for, just really smart people who want to work on Android, and that's totally fine, and I encourage it. But I think that it's also important when you're, say, building an app from scratch, that you know how Android works and don't get locked into patterns that might arise from people saying, I know Java, I can write an Android app, because you can. But the sustainability of that app might not be the same as if it was somebody who's worked with the platform for a long time and knows the pitfalls and all that sort of thing. I think there's space for both. If you're proposing like a dichotomy, I don't know if that's what you were doing, but I don't know.
Speaking as somebody who was hired never having written any Android code, I'm very pro hiring generalists and training them up. But I don't actually believe that. I think it's less a distinction between Android engineer and other platform engineers, and more a distinction between app engineers and generalist engineers. And even then, it's not as simple as that. A strong engineer can probably be strong on anything. A strong engineer who's familiar with Java is going to have more luck getting up to speed more quickly on Android. That's been our experience, certainly. So maybe that's like there's three buckets. The wunderkind engineers who can pretty much do anything and they're just intimidating. Then the app engineers who at the end of the day just want to write apps on whatever platform is coming out this week. And then the platform zealots. And you do need to have that kind of core of people who really understand and evangelize and have internalized the platform to get the rest of us up to speed and to be productive. But kind of once you have that DNA there, you can definitely draw biomass from other pools.
So I've got a different question for you, which is there such a thing as an Android designer or a general designer? And in our experience, we've not had a really strong Android designer on our team, and that is sorely missed. And so I think if you look and you say somebody who's an Android designer sort of bleeds material design and knows who Matthias's shirts, which shirts have Matthias worn and stuff like that. And so there's just certain things about the Android platform that get neglected if you're using somebody who carries an iPhone to do your design. And I think that the same is likely true for the engineering side as well.
I think that's a great point. I think that's definitely a great point that you brought up, and maybe to tangent this a little bit further, if that's something that's interesting to folks. When it comes to design on Android, I find kind of a unique situation in our space where when you're working within a team as an iOS engineer, your iOS designer is an advocate for the platform. They understand the design guideline. They have strong opinions on the way things should be done. But for most of us, when working on a team with a designer who probably carries an iPhone and may have an Android test device in their bag but doesn't strongly use that as their primary device, you are the advocate for the user experience more often than they are. They may have more brand, guidelines and things like that for your company, but it's often you pushing back saying, no, this doesn't feel right. And what needs to happen is designers really need to develop muscle memory for the platform so that they can have an empathy with the users and they can understand the pain points that their users have. And you really develop that by living with that device as your primary device, having it be your alarm, wake you up in the morning. How does it feel when you're half asleep and you're trying to interact with it? How does it feel when the battery's dying and you're trying to call an Uber? What is this experience like, and how does that drive the intuition that you have on the platform? So taking all that said and then pulling that back to engineers, right now we are the advocates for design. We don't have that design, and I think that's really important that we at least provide that. If from the API side, it's a very complex platform, right? You wouldn't say, hey, Ty, there's a bug in our storm topology. You haven't worked specifically in server engineering in a while, but could you just quickly hop in and fix that? Probably. How long is that going to take me to come up to speed on the storm topology and be comfortable fixing that with tests? Same thing for another engineer coming into the platform. They could probably do it. Are they going to be an advocate for it? Are we going to get the best user experience? I'm not so sure.
Yeah, I think it just comes down to respect for the platform. We're really lucky in that we have a dedicated Android designer. I actually don't know what kind of phone she carries, but it's I think it just, you can have somebody who, if it's their job to be designing for an Android phone, they should understand, regardless of what phone they're carrying, what it's like to be an Android user. And especially if your developers are pushing back. It's like if you have somebody saying, oh, well, we should add a back arrow because it doesn't feel natural to not have a back arrow, and we have to say, oh, no, but it's a back button already, and that's like part of the Android. You know, my point is just that, like, if you're working in this space, it's important to have respect for those users and for that platform, because you never want to work at a place, I think probably most of us have, where you're the Android developer and you get told make it look like the iOS app. I don't actually have that much more to say about this.
I almost think that like your carry phone should be like a 2-year-old crappy Samsung device, because then you'll be like, oh, it isn't actually as fast as I want it to be. Or it's crashy because that's the life of actual Android users.
I have a question. What do you think about supporting landscape?
Well, my manager's in the audience if you want to ask him about it. Do you really want me to answer that specifically about Slack? It's
not just
no,
Slack,
okay.
in general. But sure, Slack.
In general. Oh, go ahead, please.
No.
In general, I think for some applications, if it's the kind of thing that somebody's going to be using, for example, on a tablet, or if it's Netflix and you're going to be watching it in landscape anyway, then it makes sense. It often is something that kind of does fall to the wayside, I think, when you're rapidly developing something. Like testing or whatever.
I think on a mobile device, on a phone, it's probably more trouble than it's worth. And if I had my druthers and could go back in a time machine, maybe there'd be a few less landscape screens in my life. But I think a lot of the problems that you think you're avoiding by not doing the orientation change, you actually still have. You still have to deal with storing yourself from a process death. There's other things that cause configuration changes, but they're going to happen less often. And so you're going to be finding them at more inconvenient times anyway. And as soon as you bring a tablet into the picture, it's a lot harder to make the argument that there's one way that's right and there's one way that's wrong. You've got all of that landscape to deal with. But still, there's about, 70, 80% of our screens that I wish would go away.
So that's interesting then, the implication that there's kind of two reasons that you wouldn't support landscape, either because you want to avoid configuration change, extra kind of cruft code you have to add, or because you don't have the design resources to make that extra tablet screen, for example.
Or it's just not even compelling. You find yourself, God, I have to make a landscape version of this as well. It looks awful. It feels awful. Nobody's going to use this anyway. It fits in my hand like this, and the information is vertically oriented. Why am I wasting everybody's time? It should try to be a purely design decision, I guess, is what I'm saying. And the engineering decisions are excuses.
Agreed.
Yeah, I was going to say that argument was a lot different 3 years ago when there were phones that had keyboards. Those seem to have disappeared.
G1 forever.
Right. So I want to shift gears a little bit. I have no idea how we're doing on time, by the way.
Bond. James Bond.
There's 10 something. Okay, how long do I have? How long do we have? We don't know.
You guys have.
All right, we'll go a little longer. So this is a little deeper topic. One of your slides, Ty, mentioned architectural consistency. So I'm not specifically talking about that, but it kind of brings up a point where there's a balance you have to draw in teamwork where maybe someone on the engineering team wants to introduce Kotlin as a new language, which by itself is great, but now you have Java and Kotlin coexisting. So the overall picture is more complicated, and it could potentially add more mental space for your team to have to understand. So what are your criteria for adding new technologies versus maintaining consistency?
Well, Jesse seems very excited to answer a question.
So, as a rule, no to any fancy technology like a new programming language, like a new database, any of that, absolutely not. But Kotlin in specific, yes.
And there's reasons that he's right. Kotlin, it's like every decision the Kotlin team made was, how do we make sure that this lives with Java seamlessly so that I'm not wasting effort and I'm not wasting resources and I'm not having a huge, horrible cognitive boundary when I jump from one place to another. And especially on the Android side where we're never going to see Java 8. And I know that a lot of people are willing to kind of roll the dice with retro Lambda and figure it's probably going to keep working because how hacky could it be? Yeah, when we're at the point where Google themselves are shipping features implemented in Kotlin as part of the platform, I feel pretty confident that they're not going to break it anytime soon. And I want Lambdas so bad.
And with Kotlin specifically, it was really designed with mobile in mind from the very early beginnings from the team. So the runtime is super lightweight. It has compatibility back to Java 6. But Kotlin aside, I think your question was more about how do you evaluate new technologies? How do you get those into your app? And I think the first step with that is team alignment on exploratory work. So while you should have a consistent architecture, there's always new, exciting, and possibly significantly improved technologies coming out that you may want to migrate to. And it's your job as an engineer in a fast-moving space to always be kind of keeping a pulse on those, evaluating those, talking about those with your team, finding out which of those seem to have promise, and how you can maybe experiment in a small way.
Got some examples?
What's that?
Got some examples of those technologies?
I mean, Kotlin is a great example. I wouldn't necessarily advocate it but like Realm is another one that's been pushing in the space. It has a lot of negatives that I personally haven't been using it because of those. Like it doesn't support polymorphism. There's no immutable classes. There's a bunch of other things. However, it's another example of like replacing SQLite. Retro Lambda is another example. RxJava was this for a while. A great example with Kotlin is start introducing it in a way that's not going to impact production code to begin. Start with it in testing. Then the only impact is learning curve. It's not also affecting your customers. If you get then buy-in from your team, you see greater improvement, you can start introducing that at a broader scale based on whatever criteria you may come up with.
I don't have Kotlin opinions, but in general, I don't know. We got really lucky in the fact that we actually rebuilt our app from scratch about this time last year. So we were able to really evaluate all of these new technologies and kind of choose the way we were going to do it from the beginning. And I know not everybody has that opportunity, but it was very helpful to be able to kind of, instead of trying to shove stuff in where it might not fit or where it might break things, it was nice to be able to start with a clean slate.
So what did you pick and what did you fix?
Well, I wasn't there for the 1.0. Actually, none of the people who work on it now were there for the 1.0. But just, for example... It was bad. It was very bad. No, but I mean, just for example, deciding from the outset that we're going to use RxJava with our API calls, things like that. Being able to set that standard from the beginning, first of all, makes onboarding new engineers really easy because we can say, this is how we're doing this. You can see this pattern. You can see that this is how we're going to be doing this thing across the app. It makes it really easy to pick up the way the code base is structured. And that's kind of something you have to be wary of, I think, when adding new technologies, is making sure you find all of those little places that you might have missed it, because it can cause a lot of confusion down the line.
So what about the opposite? What about complexity in the frameworks that you've deliberately avoided because it causes productivity problem on your team? Let's say Fragments, for example.
I'll take one of these. I generally prefer avoiding any component of Android that particularly couples it to untestable lifecycle-based methods. Woo! So I'm not as opposed to Fragments per se. As a general principle, as maybe some of the folks here, I've definitely used them quite a bit. What is this? Yeah.
That's for right.
That's. But things like loaders, they completely couple your business logic with the lifecycle. It makes it really hard to test. Fragments, if you've ever seen the graphs of like what the true fragment lifecycle is, where you couple in the activity lifecycle as well, it's like, really, how do you grok that? How do you test that? It's so incredibly state-based that it's stupid. But in general, when it comes down to anything that you maybe want to be testing for productivity, if you can't necessarily decouple your business logic, then it's probably best to think about not using that.
What other parts of the Android SDK are awful? What other parts of the Android SDK are awful? I feel like I feel like there's a lot of there's a lot of things that sort of come out of the there's a lot of things that come out of like the Google developers blog where I want to be like, is this SDK that they're promoting today going to be the one that is still relevant 6 months from now, a year from now?
Data binding.
Data binding, yeah, exactly. Yeah, and that might.
I'm very happy to work in an organization that universally said, "Oh my God," and that's as far as that conversation went.
Yeah, and I think that like one thing that's difficult is that people who've been working on Android for a while have learned to have like a healthy skepticism to the new APIs being pushed by the Android team. Enums matter, but new developers aren't necessarily going to have that. Like, do these people actually know what they're talking about, or are they just like, are they just pushing some other agenda?
I'm going to add a little bit to that because there's a lot here. Data binding is specifically interesting because at a high level, it seems like a great idea. I want to, I want to compose my views in such a way that I can, have these objects that I want to provide down to them and have a little more intelligence there. But in practice, in my opinion, it drives bad developer practices. It puts you into a position where even if you understand, I want to be decoupling my logic and I want to put my business logic here, and I want to only do view-related logic with data binding here. As soon as you're onboarding new folks, especially if you have a larger team where it's not all Android specialists, you're also training up new people. Even the Google documentation has examples where you're manipulating data in the XML before you display it. How do you unit test that? Do you unit test your generated code?
No. All right, so I think we're going to wrap it up in a few minutes. I do want to give a chance if anybody has any questions from the audience. Now's your opportunity. Yeah. Just speak up and I can repeat it.
Okay. How do you measure performance of code in order to decide how to architect something? So like a simple example would be whether to put everything in a hash map and then look up indexes instead of just like going through the entire list. And then how do you measure the performance of that code like on devices and make changes in response to that?
Okay. How do you measure performance of code?
Or is it not relevant?
I'll take this. Basically, benchmarking on Android is an unsolved problem. I used to do a lot of benchmarking on Android. I worked on a framework called Caliper that we made at Google when I was working there to do benchmarking on Android, and that code has pretty much completely bit-rotted to now. And so there's no really easy way to say how fast is this particular set of code. So then when you're doing your performance, it has to be completely speculative as to what's fast and what's slow. And you'll see there's basically we've got a lot of cargo culting where we're saying, I heard that this particular API is slow, and so I will just never go near it. And this is true for all sorts of things. Enums. Enums. Never use enums. Never use.
Interfaces.
Never use. Yeah. Exactly. Right. Yeah. Exactly. Never use. Never use Java. Don't use JSON, it's slow. Don't use XML, it's slow. Don't use a database, it's slow. Don't use a file system, it's slow. Don't use a network, it's slow. Don't write apps. Don't make apps.
Does anyone have an Enums Matter shirt on right now?
Yes.
Okay.
So the advice I have that's very practical is you basically want to think about performance at a very, very macro level. So you want to think about things like, when I get to this screen, what actual things are going to happen. Is the radio going to turn on so it can go out to the network to find some data? And a lot of your performance problems aren't going to be because you used a hash map instead of an int array. Your performance problems are going to be somebody loads the screen and they see a spinner, right? And so if you optimize your app so that you're trying to say, like, where do we show the fewest spinners? That's how you write a good feeling, fast Android app. It's going to be at this macro level. If you spend all of your developer complexity taking things like enums and hash maps out of your code, you end up not actually spending the complexity where it belongs, fixing the macro problems like, do we preload data? Do we use caching? Those sorts of problems.
I think if we track anything, we track two things. How often do we crash with out-of-memory problems, which Pierre has actually made us not blind to anymore.
Solve problem.
And jankiness. I'm going from this screen to that screen, and I'm just embarrassed by how few frames actually showed up. It's not hard to put in a little bit of logging to actually give yourself a frames per second counter for that situation. And that's when you start profiling. And you see, oh, I'm spinning here and here and here. Or look, here's where the main thread got blocked. And you put that effort into getting off of the main thread there, and then repeat. I guess we're probably overdue for another bit of soul searching on that.
I think that you guys specifically had a really interesting example of where you took something that was commonly known to be a performance problem with Android, and then didn't necessarily care about that because it didn't have the specific implication that normally does. And this is the invocation handler and proxy in retrofit. So a lot of people say, hey, you're using reflection to generate those interfaces.
Oh my God, reflection.
However, in practice, you're about to make a network request. Right. What is the overhead of the network request in comparison to the reflection cost to create the proxy class for the interface? It's it's orders of magnitude larger.
And then contrast that with the creation of Dagger, right? Before Jesse got here, we used Juice, and our startup time was unmentionable.
1.6 seconds.
Or mentionable. And that was a place where clearly the reflection penalty actually mattered.
1.3 seconds. No, we got it. The reflection penalty was 1.3 seconds.
Okay. I thought you said 3 seconds. My whole argument just out the window. And even there, Dagger still uses reflection judiciously. Sorry, Dagger Classic uses reflection judiciously. And runs fast enough and is usable.
The original Dagger.
As far as the way we handle performance problems, a lot of it is actually more user focused. So perceived speed and perceived performance. Like, a user's not going to notice if you're using enums. Like, I'm sorry, they're not going to be able to tell the difference. But if you have a spinner going when you could have prefetched that message data, like, that's something they're going to notice. If you could have prioritized okay, this is Slack specific, but like if you could have prioritized the channel they were already opening to instead of making them wait for the entire, for all the channels to load, like that's something the user notices. And ultimately, I think that's the most important thing for us is having a good user experience and less like kind of nerdy like.
You didn't hear that 1,000 people switched to Campfire because they don't use enums?
Is Campfire still maintained?
Apparently, the lack of enums prevented that from happening.
I got nothing to say to that.
Any more questions? Front row.
Thanks. Chrome OS merging to Android, and what's the impact?
Who the hell knows? I'm cautiously optimistic that. I'm sorry. Chrome OS merging to Android. What are the implications? I don't know. Nobody knows yet. Google hasn't even announced anything articulate about what that actually means. I hope that what it means is that some of the plumbing on Android, where security and updates were clearly an afterthought, are going to be merged with what Chrome does, which is beautiful, elegant, and fast, and reliable and secure. I suspect that there will still be a Chrome OS and there will still be Android, and it's going to be a long time before it actually matters to us day to day.
It seems like primarily that's an org restructure right now, so I'll kind of just reiterate what Ray said. If changes happen, it's going to be quite a while.
So you mentioned that you use Zeppelin for getting red lines from designers and coordinating the designs, and it seems like it works really well for a golden path. This screen should look like this, and like this is this many pixels away from that. But at least I found that it really breaks down in once you have varying screen sizes, edge cases, error cases, and like how it actually works in practice because there's a large disconnect between the two. So how do you overcome that?
So I have an opinion on that, and then I'll give you the mic. I think the question was along the lines of when you get comps from a designer that shows the happy path at one screen size, how do you deal with all the error scenarios, the different screen sizes, the different orientations? And I think one of the biggest success stories I've seen is on one of the projects that Ray works on, which I can't speak about, but I can say that they have a process where they have weekly iteration planning meetings, and the designer is part of that weekly meeting, and they plan a demo for every Friday. So every week, they're kicking off the week with design, figuring out what are the features we're going to work on, and then they commit to giving a demo on Friday to the designers, and the designers actually grab it, play with it, and then give tons of very pointed, specific feedback to pick it apart. So I actually think that hands-on playing with the UI is much more effective than giving a million different variations of comps and wireframes and all that. I think that would just be it'd be too much work, and just getting a human to talk to someone face-to-face is way more effective at that.
Yeah, I mean, Zeppelin is no replacement for, messaging the designer, but I think it's so there's two different ways you can design, right? There's more percentage-based or responsive relative type layouts, and then sometimes you really do want like a 16 dp margin, and I think we can kind of trust each other, at least within our team, to know like, okay, this is 48 dp height for the row. Like, we know that if they turn on large text, we're not going to keep it at 48 dp. There's kind of like an understanding, I guess, that we can infer when things are meant to be exact and when they're meant to be relative, and there's always an open path there. It's a little bit tough because, say, like, I'm in San Francisco, she's up in Vancouver, but I think the way we use Zeppelin is more as it's more of an initial jumping off point, and there's always going to be discussions after that. Like, there's always going to be that back and forth. Like, I have the agency to implement a design and say, maybe this doesn't really work when, you have high contrast mode on, or maybe this doesn't really work when you rotate, or when you have a Galaxy Y or whatever, if anybody still uses those. But I think my point was more, we went through many different ways to try and communicate these things. It's like we had a Dropbox where they would just update new screens or things like that, and this just happened to be the thing that was the most useful so far.
So you're in the same time zone as your designers?
Yeah, it's great.
That's luxury. That's amazing. Some of this, I think, goes back to the point Ty made earlier about, are there Android designers or are they just unicorns? There was a lot of education that had to go on from the zealous Android using engineers to, what are the natural minimum sizes, and how do we bucket things from this form factor to that form factor, and XDPI versus MDPI and that sort of a thing. Getting into a serious, intense dialogue with our designers about what our fucking vocabulary has to be, and getting them to spend the week or two to actually create an overall design template for our app. So less about specific screens and more about these are the 5 border sizes that we use. Here's how we stack things up. Things can be 8 DPs, minimum 48 DP, clickable. What's a DP? That kind of thing. They wanted to know what was the useful way to express this stuff to us. They've also been receptive to we have to know which is the part that's going to stretch. We have to know what is a percentage, what's not a percentage. And once we make it easy for them to make things easy for us, those Friday demos become a lot more useful when we get to them. Although, to be honest, we haven't done one in like 6 months.
Yeah, I will say that we're extremely lucky to have a designer who knows Android very well already. And it's like 5 engineers to 1 designer, and that's kind of the whole team. So I don't know how this will work when we're twice as big or 3 times as big. It just, at the time, like currently, we're able to kind of trust each other that we all know how Android works, which is not a luxury maybe that everyone has.
Not to undercut what Eric said, we were doing the weekly design cadence at the outset of this project when we were kind of building stuff from scratch, and there was a whole new feature that had to happen and so on. Once we get into more of the, all the big stuff is built and now we're iterating and extending, it's kind of a more natural when there's something to demo, then we demo it type of cadence.
So I took away kind of 2 points from your question. One is, what is the technical approach to more responsive Android layouts? And then the second part, which I think is probably a little more important, is what does the process look like of working with your designer? And to the first point, I'll just point out that responsive design is nothing new. It's mostly new to folks that are trained specifically on mobile and iOS when there wasn't iPads and things, and then they kind of moved over and are just kind of a little slow to adopt new patterns. But if you come from web or desktop development before, this is nothing new at all. And working with designers that have a little more experience like that, you quickly see the differences in the mental approach. So I think that definitely a big part of that is just is a clear line of communication on the expectations at the beginning. But then the second point, which I think is much more interesting, which is about the process. It comes down to the way that you think and you communicate with your designer. Are they a resource for your team, or are they a teammate? And I think that's an important distinction, because when they're a resource, then you task them with things, you throw it over the wall, and then you expect some sort of delivery, and you take that and expect some level of polish or finesse to it. And that doesn't leave room for the dynamic iteration that comes from having a teammate where you are both stakeholders in the project, and you can sit down together and they can show you a design and you can iterate the design. Or sometimes you have designers, I've experienced this, that'll even hack on the XML and adjust the views themselves. But when you can sit down and you can literally pair on that together, engineer and designer, you come out with a much better user experience because both of you are invested in the outcome of the project.
Yeah, I think that kind of illustrates what I meant by having agency also, is like being able to not push back, but kind of have your own opinion and maybe make I can't sit down with my designer, but I can make a screenshot and send it to her and go back and forth really quickly in that way. And it really is totally different from having a separate design org that you kind of like lob stuff over to them. And, yeah. Sorry.
All right, one more question, then we're wrapping it up. Right here.
Do you think so? If you have a team that's pulling in a lot of generalists, say like you're saying earlier, like generalist engineers versus specialist engineers, do you think it's better to like have like if you have any specialists make a framework for them so that it's harder for them to like get those gotchas or mess it up, or is it better to like train them through PRs or like mentoring or whatever to actually become more specialist engineers?
I don't think that having generalists or Android specialists really informs the decision about when it's right to write a framework or enshrine a pattern. That's just kind of basic survival. Once we punted Fragments and we put together libraries to do things in other ways, there's more or less success, more or less boilerplate in ways we wish we had done it differently. But just having a way to do stuff takes a huge burden off of everybody. It's actually maybe not as great for new engineers, Android or not, because we do things differently than other people do, and I'm sure eventually we'll document it, but not so far. But just the fact that there's 5 other things that have been implemented and they all more or less do it the same way means that I don't have to invent from scratch. How do I show a screen and how do I lay stuff out, and just get to kind of focus on the actual problem at hand. It's like I think the first slide you showed in your talk just about was yes, pick an architecture. And that, it's just pick something, be consistent, and there's pros and cons to lots of different approaches. Have one.
The app I work on has basically layers of sediment, where there's the ground level. That's how we wrote code in 2012, and we learned a lot. And we wrote new code in 2013 that's much better. 2014 was a whole new beautiful world, and we're doing our best to get rid of the older stuff. But as you said, finding time to test, it's like finding time to update that code from 2012. And as you bring on new engineers, that's when that old code really holds you back, because it's hard to say our entire code base is consistent. If you follow the patterns of everywhere here, you're going to be happy.
Oh yeah, I definitely lied when I implied that. Just both ways. But I think we're at the point where we only have maybe 2 or 3 generations of stuff, and I'm sure that we're going to bootstrap up a lot of it.
And I mean, I've been that new engineer, right? And like when you join, even if you're not new to a framework, but you're new to a company, like the first few months is really all pattern matching. It's how does this company do this thing? Or maybe how does this framework do this thing? It's really comparable. Like it's regardless of which, like you said before, which architecture you pick, I think the consistency is the most important thing, either for onboarding Android experts or for training up new generalists. Like, it just makes your life easier.
And when you do inevitably realize you wish you had done it a different way, use that deprecate. Use the Java doc. If something is replacing something else, it just doesn't take that much more time to say, here's what to use instead. Here's what not to use. And here's the thing. In my deprecation comment points at the thing that should happen instead. And then there's just, we've always got to be talking to each other. It's got to be really safe for new engineers, whether they're Android developers or generalists, to come up and ask for a question. You definitely just need a culture where it is perfectly okay to interrupt somebody to get some clue, because nobody has a clue without it.
I like the idea of being the experienced Android engineer who would like potentially join, say, Ray's team, and being like, where are all the activities?
The activity's right there.
I agree with everything that's been said here about consistency and bringing people on board through that. But I think that it's also really important to think about the people aspect of that as well. And when you have a new person coming to the team, regardless of if they're a generalist or a specialist, there's going to be a learning curve for your application. It's large. You're probably doing a lot of interesting things. It's been worked on for a while. And regardless of that person's expertise, there's going to be this up-and-coming period when they're working on it. And that's where I think mentorship is really, really beneficial. Instead of tasking the person with something and they go off and work on it alone, siloed, then they submit a PR, then you rip it apart because it's not done in the way that was expected by the code base. Pair with that person up front, work with them up front, work on the architecture, the approach, get them to the point where when you see the PR, you're not, destroying it for the entire approach that was submitted, but you're nitpicking the normal things that would come from an engineer that you would expect on your team.
It just seems like it's a really common fantasy or a dream for every engineer to go back and clean up everything and just make it perfect. But you have to ship. I mean, there's code in register from 2010. I mean, we have.
You wrote it.
Yeah, I know. I think that's code for delete everything Burke wrote. So anyway, I'm actually going to wrap this up. We're going to hang out for a few minutes and chat if you want to ask more questions in person, but I know you're getting kind of fidgety and ready to stretch your legs and move on. So I definitely want to thank Haley, Ty, Ray, and Jesse for great talks and a great panel discussion. So round of applause. All right. Thanks, everyone.